Hello and welcome. And today in the week 7 second lecture, let us talk about the nature based solutions for climate mitigation. This nature based solution for climate is also often told as nature based climate solutions. But here in today's lecture we are going to discuss in general how the nature based solutions have an implications as far as the climate mitigation is concerned. And we, as you understand, as you know, the 13th sustainable development goal is for climate action. So in that sense, it becomes really important to understand how the nature based solution has implications in terms of climate mitigation. So to take this climate mitigation action as far as the nature based solution is concerned, we need some transformative changes. There is a requirement of transformative changes as far as the nature based solutions for climate mitigation is concerned. We will also have a look at the points with respect to various sustainable development goals, how it is getting benefited as far as the nature based solutions for climate mitigation is concerned. So that means few of the sustainable development goals apart from the climate action, that is number 13, are also getting benefited from the nature based solutions. Then we will discuss the multiple benefits of selected nature based solutions. So how various selected nature based solutions do offer multiple benefits as far as the climate change mitigation is concerned. And moving on to this, as far as nature based climate solution is concerned, we will also talk about how they are linked with respect to the environmental and socio-economic benefits. As far as the environmental, we will talk about the climate benefits and climate aspects. As far as the socio-economic benefits are concerned, we will talk about the disaster risk reduction. So those are two indications we will take, or indicators we will take to discuss about the environmental and socio-economic benefits. And then of course towards end we will talk about what are the various advantages along with various concerns. So we will here talk about the various trade-offs between any activities we are going to undertake under the banner of nature based climate solutions, or abbreviated as NBCS. Coming to the nature based solutions in terms of the transformative changes. Halting climate change will require radical transformative changes, the statement. So we need to slow down, we need to slow the pace and nearly stop the pace of climate change. So to do that, we need a radical and transformative change. We need urgent changes such as we need to enhance the NDCs, the nationally designated agencies, or the NDCs that countries have committed to. So whatever we have committed as far as the different nations are concerned, we need to collectively achieve that. So but what is happening, many of the countries who have already committed as far as through the NDCs, nationally determined contributions, are failing. So this is the observations of over last decade. So why we are failing? Because we need to take, or to overcome this failure, we need to take radical and transformative changes, deliver on these NDC conditions. So this helps us in terms of delivering as far as the nationally determined contributions are concerned, in terms of various commitments different nations have agreed upon. Develop and implement ambitious long term low emission development strategies. So all these countries, they need to come out with long term low emission development strategies, which is the need in terms of the nature based climate solutions. The countries, they need to promote behavioral changes and undertake new social reformations or norms. And also, as we have learnt during the COVID-19, so we need to invest in low carbon sector beyond the post or you say the post COVID recovery measures across sectors. Now, with respect to the linkage as linkage of various what you say services in terms of the provisioning, regulating and cultural services, how to maximize them in order or under the umbrella of nature based solutions for climate mitigation, so that many of these sustainable development goals can be targeted or can be well achieved. So, coming to various regulating services, we have air quality, climate regulation, food regulation, erosion regulation, water purification, pollination and carbon sequestration. Friends, if you see these fall under the regulating ecosystem services which are coming from the nature based solution or coming from the nature. So, nature climate solutions offer these regulating service. So, it gives us good air, so maintains a good air quality. It regulates the climate in various ways in terms of, let us say, the temperature. So, regulating the temperature range as far as the climate means variables are concerned. In terms of the flood regulation, so if you know, when you go for a lot of vegetation and other activities, then it regulates flood in terms of delaying the flood or in terms of lot of infiltration and all those things. And also the erosion as far as the soil erosion is concerned, based on the water forces, based on the wind forces. And then the water purification, it helps as far as the regulating services is concerned. The nature climate solution helps in purifying the water. And also pollination is one of the activities that is very much needed as far as the ecosystem or biosystem is concerned, because that keeps the population in terms of multiplication, in terms of growing, in terms of retention. So, pollination control is one of the important regulating ecosystem services that is offered by the nature based climate solution. Apart from that, all of us know the carbon sequestration through the photosynthesis route, because it withdraws the atmospheric carbon dioxide, which is one of the dominant greenhouse gases. Coming to the provisioning services, we have put three. The first one is wild food, second one is medicinal plants, third one is biomass. So, all these three fall under the provisioning ecosystem services. So, if we go for a lot of plantations and depend on the nature and nature based solutions, then we will get the provisioning services in terms of lot of food, in terms of wild food as well. And also the plants that gives us the medicinal value, including lot of herbs, shrubs and various nature based products, and also the biomass. So more of this is helping us in terms of giving us biomass, and these biomass are also used in terms of fuel burning for our food for our food preparation at home by our mothers and sisters and ourselves. And then coming to the cultural, it gives a recreation value, and also it gives a kind of aesthetic value as far as the landscape is concerned. So, all these three services, particularly the regulating services, the provisioning services and cultural services, they get maximized when they are supported with nature based climate solutions. Now, coming to the next one is the reduction in or minimization in terms of coming out with a trade off between maximization and minimization. So, what is that? In terms of water supply reduction. So, if we have more or excess of water supply, then a lot of flood and other activities will happen. So, we need to optimize it. Coming to wildlife risk, if lot of dense forest and biomass stock is there, then it will run wildfire risk. Similarly, the pollution and also the reduction in yield. So, all this needs to be optimized. So, or you say has to be optimized so that we get the maximum gain. So, what we say this? We say this as the trade off. There has to be a trade off between all these regulatory provisioning and cultural ecosystem services. Also, along with these factors, which needs to be minimized or optimized so as to receive maximum benefit of these nature based climate solutions. The nature based climate solutions supply as we mentioned these 3 ecosystem services, and they have some trade off as far as these 4 are concerned. As an example or indication, nature based climate solutions also are essential to support the global strategies, such as what is mentioned on the right hand side is to attain or to achieve the sustainable development goal targets. Along with the climate action, that is number 13, we also achieve many others. That means it addresses to hunger, it addresses to land, it addresses to partly to water, and a few linked sustainable development goal targets. Friends, let us see what are the multiple benefits. There are various benefits, or you say the multiple benefits of selected nature based solutions for climate change mitigations. So, what we did in this table, which is little projected in a grayscale taken from the report, which is also given at the end of the reference, at the end in terms of the reference, though it is not exactly put here, but at the end the reference is there. So, what we try to do? We try to put the biodiversity and ecosystem services in terms of the nature based climate change mitigation. So, on this you can see on the left hand side column, we have mentioned the avoided forest conversion, reforestation, improved plantations, natural forest management, trees in croplands, avoided peatlands impacts, peatland restoration, avoided coastal impacts, and coastal restoration. And on the right hand side, these columns are divided into 2 broad components. One is having the environmental benefits, and other one is having the socio-economic benefits. Under the environmental benefits, we have the biodiversity conservation, climate stability, soil health and water quality. And under the socio-economic benefit, we have the reduced risk of extreme events, food and or energy provision, cultural services, and health security. So, with this, let us see taking the climate stability as an indicator of environmental benefit and the reduced risk of extreme events as an indicator of socio-economic benefits. Let us try to understand through some examples and through some quantitative estimation the benefits given by or offered by these ecosystem services. Yes, friends, as far as the avoided forest conservation is concerned. So, let us see with respect to the climate stability. So, avoided carbon emission and continued carbon sequestration. So, if we go for avoiding the forest conversion, sorry, it is forest conversion. So, if we avoid forest conversion to non-forest lands, then what we do? We avoid carbon emission, because the moment you deforest, you convert the forest to a non-forest land, then perhaps you are losing the forest, you are losing the green plants. So, in terms of so let us look at the first one is avoided forest conversion. So, in terms of conversion, we see that the climate stability, the first point, and second is the reduced risk of extreme events. So, what we do here? So, let us say we avoid the forest conversion. The moment we avoid the forest conversion, we are retaining the natural vegetation or the vegetation component as such. So, that means we are avoiding the carbon which is within the plant material to not to go out. Not to go out means not to be emitted out. There are other routes also, but if we are not burning, then we are particularly avoiding the carbon emission going or escaping to the atmosphere from the plant parts. And second, if we are retaining that means we are continuing with the carbon sequestration in terms of photosynthesis. It is withdrawing the atmospheric carbon and storing it in the plant material. So, that means it helps in carbon sequestration. So, First point is very important, that means avoiding forest conversion. Then mostly the examples have been seen in terms of humid tropical forest where a lot of carbon is stored and also sequestration is happening, also high biomass temperate forest. Now let us move to the third point, that is the carbon sequestration from atmosphere. So what we try to see, as far as we avoid this forest conversion, so lot of carbon will be retained in terms of sequestering from the atmosphere through the same process of photosynthesis. So it has been estimated that during 2001 to 2019, about 16 plus or minus 49, so 16 to 49 gigatons of carbon dioxide equivalent is sequestered in an annual scale by these forests or by these humid tropics and high biomass temperate forests. So it is a good amount of carbon sequestration by this forest. And the third point is tropical evergreen broadleaf forests, they contribute to 20% of the global evapotranspiration. So that is how, see, look at this, so with respect to the evapotranspiration through the process of transpiration and evaporation, these broadleaf forests, particularly the evergreen broadleaf forests, they contribute up to 22% of global evapotranspiration. So that means they help in recycling of the moisture within this water body, plant and the atmosphere, within these three spheres. So in that way they play a major role in regulating the precipitation regime. Now look at the socio-economic aspect in terms of the reduced risk of extreme events if we avoid the forest conversion. So if we avoid the forest conversion, that means the erosion prevention by physical buffering of the highest stream flows and prevention of flash floods. So that is how this forest, this natural vegetation, they support or they prevent the erosion. They offer a kind of physical buffering to the high stream flows, and also they prevent or they allow to prevent thereby the flash floods. Let us move on to the next one is reforestation. So first one is the avoiding the forestation, and second one is reforestation. So in terms of reforestation, as far as the climate stability and reduced risk of extreme events are concerned, in terms of climate sequestration, mainly in humid tropic or temperate regions, and natural regeneration. Look at this natural regeneration. If you just leave it like this, where the areas where there are gap within the forest, it will go up to 9 to 19 tons of carbon dioxide sequestration per hectare per year. So it is also a huge amount in terms of carbon dioxide sequestered through the process of natural regeneration, and that is why this offers towards climate stability. Coming to reduced risk of extreme events, in terms of the reduced soil loss to erosion. So as far as the reforestation is concerned, there are reduced soil loss in terms of erosion associated with reduced compaction and greater infiltration, regulation of water flow, stabilizing the so by regulating the water flow, it stabilizes the supply in the face of both intense rainfall or drought, and this is also happens in case of reforestation of the upland areas. A recent review indicates that the benefits of up to 19% of reduction in peak flows by riparian forest restoration at sub-catchment scale represents 20 to 40% of the total catchment area. So coming to the next one is the improved plantation. So avoiding the conversion of the forest, reforestation, that means leaving regeneration or allowing regeneration within the forest. Now moving on to improving the plantation. So climate stability, reduced risk of extreme events. So planted forest and wood rods with the highest carbon dioxide removal rates compared with natural regeneration. Agroforestry and mangrove restoration ranging from about 4.5 to 40.7 tons per hectare in terms of carbon dioxide per year during the first year of growth. Look at the amount of carbon dioxide sequestered by this agroforestry or these new plantations in the first 20 years, which is considered as the significant which is considered as the growth phase as far as a plant is concerned. So, initial 20 years these plantations they sequester very high amount of carbon dioxide, 4.5 to 40.7. So, you can roughly say 5 to 41 tons of carbon dioxide per hectare per year. So, this is a very huge amount of carbon dioxide fixation by these plantations. But what are the risks in terms of reductions, risk reductions as far as this nature based solutions is concerned? The riparian planting has been undertaken as a part of integrated approach through the complying to nature based climate solutions. So, that has led to lot of flood alleviation in United Kingdom. So, in buffering against the extreme events or natural hazards such as floods, storms and landslides, and this also helps in reducing the damage impacts. Now, let us move on to the next one in terms of the mitigation from three sectors. One is the natural forest management, second is agriculture, third is the trees in cropland. So, first is in terms of the climate stability coming from the natural forest. Yes, it depends on the end use of the forest products, and there are synergies for tree growth accumulating the carbon which remains a store for the lifespan of harvested wood products, as well as from fossil fuel substitution in energy and the construction. Coming to the next one, as far as the agriculture is concerned, the soil carbon storage particularly have a lot of potential. The potential is limited by short duration of cover crops in most planting systems, and also potential conflicts with the crop production and benefits that are easily reversed if the cover cropping is discontinued. So, what we mean to say, the crops the covers on the crop is extremely important to arrest the soil carbon, or more particularly the soil organic carbon, and also in terms of what you say, the soil erosion. So, if we cover as means in many nature based solution ways, suppose we put any other creepers, that also is a useful crop on the ground. So, it covers the ground, and also it protects from the erosion as far as the soil carbon loss and other things is concerned. And on above ground you can also take any other kind of plantation or agricultural crops. So, some nature based solutions helps here. Coming to the third one in terms of trees in the cropland. So, as far as the trees in the cropland is concerned, these are the associated in terms of agroforestry, the associated with carbon storage in trees, and it has lot of potential if it is generally less than 1/3 of the potential which is emerging out of the avoided deforestation and reforestation. But what are the reduction in terms of risk from the trees in cropland? So, reduced erosion associated with reduced compaction and greater infiltration. So, this is what is increases with number and coverage of trees and will vary from location to location. So, all three are concerned with respect to natural forest management, agriculture and the trees in the croplands. Let us also have a look at the peatlands. In terms of, all of us know the peatlands or wetlands, these are a kind of marshy lands. So, as far as the avoided peatland is concerned or climate stability is concerned, so avoided carbon emissions and continued carbon sequestration in trees and soil, mainly in tropical peat forest and temperate and boreal peat forest with soil carbon. The peatlands, they store about 30% of the global soil carbon, such a rich areas. 30% of global soil carbon are stored in these peatlands and wetlands, which is a cumulative of your water body, scrubs, grasslands and lot of or the deposition, lot of deposition in terms of nutrients. So, because these peatlands, they provide enormous long term carbon sink, because undisturbed peatlands are a critical global asset in the efforts to regulate climate. So, we need to create, conserve, save and retain as much as peatland as possible, because this has a potential to store as much as 30% of the soil carbon. So, we need to avoid the peatlands from getting converted to anything else. So, if we do that in terms of risk reduction, the peatlands and wetlands, the soils, they also contribute towards attenuating the flood impact. Coming to the peatland restoration, climate stability and the risk reduction. As far as the climate stability is concerned, restoring peatlands could avoid the greenhouse gas emissions equivalent to 12 to 41%. So, it varies 12 to 41% of the remaining greenhouse gas budget for keeping the global warming below 2 degrees. So, if you link it to the global the greenhouse gas budget and the global warming potential and all those things. So, it will retain, if we restore a lot of peatlands, then perhaps we can very well match to the target of retaining the temperature rise by 2 degrees centigrade. Carbon sequestration, particularly the potential, will depend on how much methane is emitted. So, as we know, a lot of methane are generated from this peatland. So, we need to understand how much is this, and which may also offset some potential gains. This is so as we know, methanes are emitted from these wetlands, and though they also store a lot of carbon, particularly soil carbon and other carbons in terms of the diesel carbon also, we need to have a critical balance, so that the storage does not offset, so that carbon sequestration does not offset the methane. So, this is not well known, we need to work, and lot of work also needed to be done. The ability of peatland re-wetting to climate change mitigation depends strongly on climate zone and current land uses. So, the ability of these peatlands re-wetting to climate change mitigation depends strongly on climate zone and the current land use. High potential tropical peat soils, medium potential, temperate, and so the high potential is there for the tropical peat soil, and medium at the temperate and boreal level, and the low potential is there at again the boreal forestry, where the peatlands are a bit drained out. So, reduction of this greenhouse gas emission from peatlands drained for different human activities after re-wetting varies from 2 tons of carbon dioxide per hectare per year up to 34 tons of carbon dioxide. So, this is a kind of quantification in terms of how much is retained in a peatland which is restored. So, based on this high, low and medium potential, this may vary from 2 to 34 tons of carbon dioxide per hectare per year. It is also a very huge amount. Look at the afforestation what we discussed before. In afforestation, these faster growing vegetation or the plants, in first 20 years they are sequestering or withdrawing the carbon dioxide to the tune of 5 to 41 tons. Here, in terms of the peatlands, if we retain them properly, if we restore them properly, then perhaps 2 to 34 tons of carbon dioxide per hectare will be retained. So, it is very much comparable. As far as the extreme events are concerned, the peatland restoration can alter the catchment runoff regime, reduce the peak flows, and contribute to natural flood management NFM and small, that means less than 20 kilometer square catchment scale, with some evidence from modeling that peak flow reductions could potentially extend into larger catchments. As far as avoided coastal impact is concerned, from climate stability point of view, carbon storage in both above and below ground in terms of mangroves, they may store up to 1500 gigatons of organic carbon that is stored in the soil, particularly 35%. And a blue carbon project in terms of Mexico has seen that avoided emissions up to 2.84 millions of megagrams of carbon dioxide over 100 years have been estimated. In terms of the reduction, as far as the extreme events are concerned, it will lead to giving resilience in the face of sea level rise, and also store water as much as 9 to 14,000 cubic million of water per hectare, and also 39% of the people who are affected by coastal flooding will be benefited, and also the mangrove they protect about 15 million people from flooding every year, and the cost factor could go up to, if you have a US dollar parallel calculation, it goes up to 65 billion in terms of protecting the flood protection services. So, healthy mangroves can be an effective defense against the destructive impacts of tsunamis, and can reduce wave heights by 5 to 30%. Let us move on to the next one is the coastal restoration. Here, as far as the mangrove restoration is concerned, carbon sequestration to the tune of 23 to 10.5 tons per hectare of carbon dioxide can be restored in the 23 tons of carbon dioxide per hectare in first 20 years, and 20th to 40th year another 10 tons of carbon dioxide can be restored. So, this is also in terms of quantification, and it also helps in terms of retaining the blue carbon, the carbon which is retained in terms of tidal marshes, seaweed grass, and also the mangroves. We put them under the blue carbon, and the reduction of biomass up to 80% plus or minus 30%, and soil in terms of this can be retained. So, this has huge contribution as far as the climate stability is concerned based on the nature based solution. As far as the reduction risk, we have the extreme weather events in terms of offering the climate change adaptations, and also benefiting from the damages caused by the storms. Now, the concerns, as we discussed, we have a set of involvement in terms of afforestation, land restoration, biochar reuse, and also sustainable land use practices. So, this takes us in a low cost. So, NBS based climate mitigation leads or goes in a low cost and greenest way, and it has multiple it offers multiple ecosystem services as we already discussed, and also the nature based climate solutions also have another impact what we have discussed in terms of trade off. So, what are the trade off? The trade off is associated in terms of expanding the ecosystem area vis-a-vis improving the ecosystem management efficiency. So, maintaining a critical balance between these two is extremely important. To discuss this, we have taken help of these two references or citations, and to conclude, yes, these points we mentioned in the concept. So, we have discussed about the various needs as far as the transformative changes are concerned, how these attribute to various sustainable development goal targets and multiple benefits, and in elaboration we discussed about the climate benefit as far as the environmental is concerned, and the risk reduction as far as the socioeconomic benefits is concerned. And towards end we discussed that all said done, we need to maintain a trade off between the amount of storage and between what we need in terms of the expansion and the quality. So, with this I must thank you.